Okay, so what we're going to do is we're going to take what we've learned and kind of step forward with it. We're going to move from factoring and solving by factoring into graphing the key features of quadratic. And we're talking about basically graphing it when it's in what we call intercept form. Intercept form is when the quadratic has been factored, and then we can use those factors to solve. So let's take a look at this example, and we'll work through this step by step. All right, so the factors of x squared minus 4x minus 32, by the way, we need to double check to make sure that the quadratic is set equal to 0, and it is. We're going to go ahead and factor that. And through your process of factoring, you should find that it is going to be the factors x minus 8 times x plus 4 that will equal this quadratic. Then we're going to find the solutions. So x minus 8 will be set equal to 0, and x plus 4 will be set equal to 0. None of this should be new because we've been reviewing this. Add 8, of course, to both sides in order to get a solution of 8. Subtract 4 from both sides to get a solution of negative 4. So our two solutions for this quadratic are 8 and negative 4. We're going to use those to state our x-intercepts. As we saw when we graphed these, the solutions are actually the same thing as the x-intercepts. So the 2 points where this graph will cross the x-axis are the points 8, 0, and negative 4, 0. Again, the two solutions give us the points or the places on the x-axis where this graph will cross through the x-axis, otherwise known as the x-intercepts. Okay, so we're going to take these x-intercepts and we're going to find what we call the axis of symmetry. The axis of symmetry is this vertical line that passes through kind of the middle of our quadratic graph. It sort of splits it in half, and it's called an axis of symmetry because it is the point, or excuse me, the line of reflection. So when we have a quadratic, we know it's a parabola, and we know when we fold it over, if we fold it over on a particular line, the graph matches up. So that particular line is called the axis of symmetry. So it's essentially halfway through and goes through a vertex point. The way we find it is we know that it's the line that's halfway between these two values. So if it's halfway between these two x values, the way we're going to find it is to say, well, that must mean that it's the average of those two values, because the number that's halfway between 8 and negative 4 is going to be the average of those two numbers. So this is what we're going to do. We're going to say, great. So the axis of symmetry is where x is equal to, we're taking the average of 8 and negative 4, so 8 plus negative 4 divided by 2, that's how we'll find the average. When we do that math, we're going to find that 8 plus negative 4, of course, is 4, divided by 2, and you're going to get 2. So it's the line where x equals 2. So let me show you what we have so far. We have the x-intercepts, 8, 0, and negative 4, 0, right? So negative 4, 0 is here, 8, 0 is here. Those are those two x-intercepts. They represent the solutions. And then we have this line that's called the axis of symmetry that we know goes halfway through our final graph. So this is a vertical line where x is 2. This is where x equals 2. And I'm going to put sort of a dotted line through this vertical axis where x equals 2. That is the line of reflection for our graph. All right, now we're going to move on to what we call the vertex point. The vertex point is the point where the parabola for the quadratic basically turns and goes back to where it came from or changes direction. So it's a single point that will be on this axis of symmetry, and it's where the parabola changes direction. So the vertex point, like we said, is on the axis of symmetry, and it is a point where x equals 2, because if it's on the axis of symmetry, the x value of that point has to be the same as whatever the x value is for the axis. So for our particular problem here, It's where x equals 2. It's 2 that we're going to use for the value of x. What am I going to do with that value? Well, I'm going to plug it back into our original equation for x and solve for the y. So that means that we originally had x squared minus 4 times x minus 32, and we're trying to figure out the y value for this point. So I'm going to plug in the x value of 2. So 2 squared minus 4 times 2 minus 32, and then we have to figure out what does that equal when we do all of this math. All right, so what does that equal? Well, it's going to equal, let's see, this is 4 minus 8 minus 32, right? And let's see, 4 minus 8 is negative 4. Negative 4 minus 32 is negative 36. So we're saying that our y value is going to be negative 36. So the x is 2, the y is negative 36, so the vertex point is at the point 2, negative 36. I'm going to place that on my graph. So 2, negative 36 would be right about there. So that's the vertex point. So we have sort of the general shape of our quadratic. Now remember, these things are parabolas, not V's. They actually are smooth curve parabolas. One last thing we need to find is the y-intercept. Now I'm going to give myself a little room to find the y-intercept. This is how we're going to find the y-intercept of this graph or this equation. Now the y-intercept, you should recall, the y-intercept is where any graph passes through the y-axis. Okay, so we're talking about where it's going to pass through the y-axis. Now, if it's passing through the y-axis, that is where x equals 0, because we have not moved. If we're still on the y-axis, we have not moved to the right, and we have not moved to the left. So it's always going to be, for the x-intercept, it's always going to be where x equals 0. It's always going to be where x equals 0. Well, that's really convenient because that means that all I have to do is plug in 0 into my equation, replace the x's with the value of 0, and then I will always know what my y-intercept is. So I'm going to take this equation and replace the x's with 0, which you're going to quickly see means the only thing left when we're done with that, this is going to 0 out, this is going to 0 out, so the only thing left, the only value left is the constant, which is 32. So the y value for this is negative 32. So the point for this particular problem, that is the y-intercept, is the point 0, negative 32. So I'm going to place that point on my graph. So 0, negative 32 would be approximately here. So I know that my graph, and I haven't labeled the points on the graph yet, but I know that my graph needs to pass through, it's the parabola that passes through all of these points. There is a reflective point of the y-intercept that is going to be the same distance away from this axis of symmetry, since this is sort of the reflective line. This point is 2 units away from the axis, so if I go 2 units in the other direction and put a reflection point there at the same y value, now I have a better idea of what the shape of my graph will look like. So now I'm going to just try my best to sketch this thing as a nice, smooth parabola going through my graphed points. And then, of course, I should label all of the points that are on my graph. So this is 8, 0. This is negative 4, 0. This is the vertex point, which we found is 2, negative 36. My y-intercept point is 0, negative 32. And if I want to figure out where this is, I know it's at a height of negative 32. All I have to do is figure out the x value. It was 2 units past. So here we are. It's at 4, negative 32. And now I have a complete graph that represents my original equation.